Yes, a raceway containing a cold water bonding conductor is treated the same as a raceway containing a grounding electrode conductor. Both are required to be bonded at both ends. If the raceway is broken to bond to building steel, the ends of the broken section are not required to be bonded. Only the beginning end of the raceway and the end at the cold water pipe need to be bonded. A locknut is sufficient for bonding the raceway where it originates if the locknut is made of a conductive material, such as copper or aluminum. Otherwise, an additional bonding jumper is required. Now let's delve into the specific requirements according to the National Electrical Code, NEC. NEC 250.64. A2 states that the equipment grounding conductor shall be connected to the grounding electrode conductor, the grounding electrode, or both, at each electrical panel board or switchboard and at each service or equipment disconnect. This section emphasizes the importance of connecting the equipment grounding conductor to the grounding electrode system at key locations within the electrical system. This ensures a low impedance path for fault current, which is crucial for the proper operation of overcurrent protective devices like circuit breakers and fuses. By connecting the equipment grounding conductor to the grounding electrode system at each panel board, switchboard, service, and equipment disconnect, a robust and reliable grounding network is established. This network minimizes voltage potential differences between metallic parts of the electrical system and ground, reducing the risk of electric shock hazards. It also facilitates the clearing of ground faults, thereby protecting equipment and personnel from potential damage and injury. Now considering NEC 250.64. B. The grounding electrode conductor shall be installed in a raceway that is bonded at each end to the grounding electrode system. This requirement addresses the protection and bonding of the grounding electrode conductor, which is the conductor that connects the electrical system to the grounding electrode, such as a ground rod or water pipe. When a grounding electrode conductor is installed in a metallic raceway, such as electrical metallic tubing, EMT, or rigid metal conduit, it's essential to bond the raceway at both ends to the grounding electrode system. Bonding the raceway ensures that it is electrically continuous and provides a low impedance path for fault current. If a fault occurs on the grounding electrode conductor within the raceway, the fault current will flow through the raceway back to the source, tripping the overcurrent protective device and clearing the fault. Bonding at both ends of the raceway minimizes the impedance of the fault current path, which helps to ensure that the overcurrent protective device operates quickly and effectively. Also, bonding the raceway helps to prevent voltage potential differences between the raceway and other grounded metal parts, reducing the risk of electric shock. NEC 250.64. C states where a ground fault circuit interrupter, GFCI, is installed in a metal raceway, the grounding conductor shall be bonded to the raceway at the line and load ends or by a jumper installed at the ground fault circuit interrupter. This section addresses the specific bonding requirements for metal raceways that contain ground fault circuit interrupters. A GFCI is a device designed to protect people from electric shock by monitoring the current flowing in the circuit. If the GFCI detects a difference in current between the supply and return conductors, it indicates a ground fault and the GFCI quickly interrupts the circuit. When a GFCI is installed in a metal raceway, it's important to ensure that the grounding conductor is properly bonded to the raceway. This bonding provides a low impedance path for fault current and helps to ensure that the GFCI operates correctly. The NEC specifies two acceptable methods for bonding the grounding conductor to the raceway. Firstly, the grounding conductor can be bonded to the raceway at the line and load ends. This means that the grounding conductor is connected to the raceway at the point where the circuit enters the raceway, which is the line end, and at the point where the circuit exits the raceway, which is the load end. Secondly, a jumper can be installed at the GFCI to bond the grounding conductor to the raceway. A jumper is a short length of wire that is used to connect two or more points in a circuit. In this case, the jumper would be used to connect the grounding conductor to the metal raceway at the location of the GFCI. By bonding the grounding conductor to the raceway using one of these methods, a low impedance path is created for fault current. This helps to ensure that the GFCI operates quickly and effectively in the event of a ground fault, protecting people from electric shock hazards.